This review is intended as a preparation for your structural design criteria code, structural manuals, and technical tables quiz that you will be taking in your structural drafting module. If you have your Canvas open, you can take a look at your modules. I'm going to go ahead and in Student View, I'm going to go ahead and go to Modules. If you take a look at your listing of modules in there, you'll notice that the module for structural design criteria codes, structural manuals, and technical tables is grayed out. That means there are prerequisites for it. It means you have to complete the previous module, structural design criteria, loads, and forces, before you can open up or unlock the module with the quiz onto that. Notice there are two parts to it, presentation and quiz. I'm going to go ahead and leave Student View, and we are going to go into the presentation portion of it for the tables. Very, very important that you review and read this page. A lot of the questions that you're going to have are going to be referencing this page. A lot of the questions will also be referencing some of the links which are included on this page. A couple of examples are potentially the Florida Building Code or the International Building Code, the Residential Code, etc. And click on those as you're doing the presentation so you learn how to navigate through those. As an example, if I was to click on the International Building Code and I open that up into here, learn how to navigate this website. The website is structured very easily in terms of being able to navigate it. On the left-hand side, you have a column here that has a number of the chapters and sections that you need to deal with, all the way from scope and administration on chapter 1. And as you scroll down, each one has a different reference to it. For example, chapter 6 is the types of construction, chapter 10 means of egress, and so on as you go down through that. The body of the code is located in the center of the page, and you can scroll down through that pretty easily. Also be aware that some of these chapters will also have sections inside of them. So as an example, if you go into chapter 19, concrete, you'll see that there are sections 1901, 1902 definitions, etc. And also if you start scrolling through them, some of them may have some tables that you may need to reference. This one unfortunately does not, but some of the other ones will have that you can you will need to reference them onto that. So let's get out of that into there. Let's go ahead and let's get back to our presentation. I'm going to try to access the International Building Code again. There we go. So be aware of how to navigate this one. It's very important. Another one that you're going to need to do the same thing is the International Residential Code, 2008. The structure for all of these is almost identical, but be careful. Make sure you are in the right code that the question is asking for. Very, very important to be able to do that. So once again, go through this entire code into here. Let's see if we go to one of the chapters. There's the body of the information and the code right into there. As I scroll down, you're going to see some diagrams. Here are some of the tables you may need to access onto there. Learn how to navigate through those. Very, very important that you understand what the design criteria is on some of these tables. Everything is pretty well laid out for you on this. So for example, in this table it talks about joist spacing. This is for floor joist spans. It's in the chapter dealing with floors onto that. So take a look at it. There's the size of the lumber. Also take a look at the reference up in here for the table. Tells you what the live load is going to be. And here we have two sections right in here dealing with two different dead loads, 20 PSF, 10 PSF. Make sure to read the question for what the design criteria would be. So based on the species and grade that you may have to answer, the spacing, and the size of the lumber and the dead load and the table itself, you should be able to figure out what the maximum floor joist spans are available for certain species, for certain joist spacing, or if we give you the span, you may need to select the spacing and species of the lumber to be able to use into it. Let's go back to the presentation and look at a couple of other things that may be on the quiz. Again, please click on as many of these links as possible. They will have information for you onto that. Scroll on down through there. Another one that's you may have some questions and is an interesting site is right here, the U.S. map of codes. So if we click on that, what you're going to get is a diagram like this with all the different states, and as you hover over them, you can go ahead and click on them. As an example, if I was to click on West Virginia and I scroll down, right in here I have West Virginia, and it tells you the current codes and additions adopted in here that West Virginia is using. Now, there may be more than one code. There may be a series of codes. The questions may be posed to you a little bit in a different way. As long as the answer has one of these codes, it would be correct. So make sure to take a look at what you're going to be doing there. So if we go and take a look at the quiz itself, let's take a look at the quiz. Before you start, I'm not going to preview it at this point, but one other thing you're going to need to do is to make sure up here in the instructions, okay, there are 4 more reference tables or standards that you will need to download. So go ahead and click on those so you have them accessible to work with. Some of the questions will be referencing those tables and design values. So if we go through a couple of these, let's go ahead and let's try one of them right in here. As an example, span tables for joists and rafters. If I ask you to reference some of the tables in here, what you need to do is to scroll down, find the proper table in here, okay, whether it's floor joists or whether it's rafters. Pay close attention to what it is. Here's your design criteria being requested. Is it for 30 pounds live load? Is it for 40 pounds live load? There's a deflection limits right into there. And here it goes for the dead load, the 10 PSF for the dead load. Here's your joists, the sizes, 2x6s, and the spacing in here. So if I'm asking you to find the span available for a 2x8 space at 12 inches on center, I would look along this entire top row across in here. One other piece of information I would have to give you is what's called the modulus of elasticity, and it's located along this row right up in here. So you should have all that information available for you. Again, pay close attention to the table name itself. Again, here's one that deals with rafters. The one we were previously on dealt with floor joists onto that. Let me go ahead and close this one, and let's go ahead and open up another one in here. This one has to do with design values for joists and rafters. So once again, you're going to be dealing with tables onto this. So here's something important that you may need to find out. So here are your design values for joists and rafters, visually graded. You have your type, your species here, and your grade. There's your size of it. And here you have your design values in bending FB right in here. So you have to pay close attention to what I am asking on there, on these charts. Okay, let's close that one up. You're going to have a couple of more you're going to be dealing with. One of them will be this. This is an abbreviation of the actual steel construction manual. The steel construction manual actually is a book about 2 or 3 inches thick. This has just some relevant tables and references that have been abbreviated into a very, very short version into here. So if the question is asking about steel, make sure to take a look at the proper tables that you're going to be looking for, whether it's properties, whether it's going to be dimensions of specific beam sizes or steel column or beam sizes. Remember, a W36 by 256 means it's a W form. It's 36 inches deep roughly, and the weight of that beam is 256 pounds per foot. So you have W36 by 256, W36 by 232. So here it gives you some of the sizes, areas, weights, etc. for those W shapes, those steel beams. If you continue down, you can see again some additional information here for W shapes in terms of finding what the maximum bending moment might be for some of those onto there. I'm not sure if you're going to have any questions on that. You have two sets of columns. The ones that we use are LRFD columns onto there. These are two different criteria used in analyzing that. And then here we have maximum total uniform loads for different shaped beams or columns or steel type of structures. Here's a W36 and also a W33. You have one set of columns here for the 36, one set of columns here for the 33. Here are your weights per foot, 160, 150. These are your spans that you may be asked to find. And then once again, here we have the maximum loading that you have for this type of beam. So here's an example. If I ask you to find the maximum span for a W33 by 221, which means it's a 33 depth beam or column, and the weight per foot is 221. And I'm telling you, well, what is the maximum weight that I can expect on that beam if I have a span of 32 feet? So I would need to come across all the way across this row right in here to the 221 or the 201, whichever one I said, and here is your maximum load. In this example, it might be 725, and it's measured in kips. So make sure to put the values in there, or when you read the answer, make sure the answer is in the correct. Kips is the equivalent to 1,000 pounds. So as you continue through this, you can see that we have different shapes. That's going to give you the values for the maximum loading, uniform load that you can put on it for specific spans and for specific sizes. Just once again as a reminder, use the LRFD columns to get the values. And once again, they are in kips. If you continue coming down through this, it's got some additional information that you may or may not need onto there. Let's go ahead and let's go to the last, I think, manual that we're going to be using. This one is the companion to the AISC, the American Institute of Steel Construction. And there, this one has to do with Volume 2, the design tables. So if you scroll down through there, what you're going to find is, if you go through the beginning with a lot of different calculations and so on, go ahead and continue to the tables. And here you have the type that we're looking for in terms of the available strength in axial compression for this type of shape in there. So this is for HSS 16s. So here we have an HSS 16 by 12. Here's an HSS 16 by 8. And the number directly under those two, if you notice in here, let me go ahead and zoom in a little bit. You have 3/8 inch, 5/16 inch. Here you have 5/8, 1/2, 3/8, 5/16. If you look at the member up in here, the composite, it says filled rectangular. That means that they've actually filled the middle of this with concrete. The reference here to the 3/8 or 5/16 has to do with the thickness of the metal that is going on there. So it's using a 1/4 inch or 3/8 inch thick wall onto that. So scroll down, look at the shapes. If you are asked to give an answer regarding the maximum axial compression. Okay, find the shape, find the thickness of the metal into there, and make sure to use your LRFD into there. And over on the left along here is your effective length for that. So if you had available strength for, let's use as an example in here, let me go to a bigger size so I can see it, for an HSS 8x4 with a wall thickness of 5/16 of an inch, and I'm asking what is the available strength in kips, in axial compression, for this member for a span, what we call an effective length of the column at this point, of let's say 12 feet. I would go across this row right into here and find it accordingly here using the LRFD columns to be able to do it. Once again, good luck on the quiz. I think that should complete most of what we're going to be covering onto there. Good luck.